Okay, so in Spark, we have two types of operations, right? When we talk about operations, what kind of thing, what we can do when we work with Spark. So the operations are basically divided into two categories. The first one is transformation, and the second one is action. It's very simple to understand. The transformation means whenever we need to do some changes onto the data. Transformation means when we want to do some changes, right? Action means when we need to have some result, right? So when we want to do some changes, now we know that when we work with Spark, the basic unit of abstraction or the basic unit of computation is RDD, right? In Spark, we have RDD. And there are three major properties of RDD, right? So the RDDs are resilient, they are distributed, and obviously their data set. When we talk about resilience, resilience is achieved by immutability. Immutability and partitions plus some partitioning, right? But now when we talk about transformation, we are talking about changing the data. So the question arises, if RDDs are immutable, then how we are transforming them? So the answer to this question is, whenever we change a RDD, whenever we do some transformation onto some RDD, a new RDD will be created, and the value will be assigned to this RDD. So let's say we have an existing RDD, RDD1, and we do some transformation over it, a new RDD will be created. But this will not be taking place in reality, right? So for example, let's say the RDD1 is reading a file, RDD2 is RDD1 plus filtering, and then RDD3 is RDD2 collect or show. Then when we do this kind of thing, then these first two things will consider in transformation, right? Because here we are only telling the system or telling the Spark that, okay, read a file, do some filtering, but in this particular action, or we don't call it RDD, we just call it action. In this particular action, we are collecting the data. So what is going on behind the scene? Two things. First thing, that RDDs cannot be changed. Whenever we change RDD, a new RDD will be created, right? RDDs are always val. Val means immutable. So whenever we change the RDD, a new RDD will be created, right? That's the first thing. The second thing is, we can have two types of operations on RDD. The first is transformation and the second is action. So when we talk about transformation, transformation are the function that takes an RDD as input and produce one or many RDDs. They do not change the input RDD, since RDDs are immutable and hence we cannot change them, but always produces new RDDs. The new RDDs can be one or many, right? The best example of transformation is map operator. So what map operators do, it just maps the things to all the input lines. So let's say we have words like I am Nilendra, right? So we have three words. If I want to put one in front of every word, so what I'll do, I'll run a map function on this line, and if I want to run a map function, and in the map function I want to write put word comma 1. So what it will return to me, I 1, am 1, and Nilendra 1, right? So basically what map is doing, map is just changing the RDD. It is not giving you the result, right? It is internal. So in simple words, what transformation do, transformation won't give you any results, rather than they will just perform some activity for the computation, right? what that activity is, they will create a new RDD with some logic what you have performed in the previous RDD, right? Now the question is, you can perform n number of logics on RDD. On RDD1, you can say some filtering, right? Filtering, then sorting, then something else. The thing is where we are storing this logic, like on which RDD what we have performed. So what Spark is doing for you guys, it is creating a directed acyclic graph, right? So it is creating a directed acyclic graph. In this graph, so let me cover a bit about directed acyclic graph. So in directed acyclic graph, what Spark is doing for you, for every RDD, it is creating a node. For every transformation, it is creating the edge. And then once that transformation has been done, this transformation, it is creating a new RDD, right? So let's say from RDD1, you have created two transformation. This is, let's say we have 1 to 100 number here, and you want to add each number with +1, and you need to create a new RDD. And here you need to add +2, and you need to create RDD2. So RDD2, RDD3. So what transformation you did here? You just mapped each RDD1 and map each number, add each number with +1 and here +2, and created two more RDDs. And then you union them, you union these RDDs, and you created a new RDD, RDD4, and you hit some action, and here is the result, right? So whenever you hit this action, this whole RDD will go into, will create a DAG, like this whole transformations will go into a data structure called DAG, right? What DAG stands for? Directed acyclic and its graph. So we can see that, okay, this is directed, this is going only in one direction, and this is obviously a graph. Graph means edges and vertices, right? So it is directed acyclic graph. So what is the major benefit of DAG? So the major benefit of DAG is, since the DAG is only executed once we hit the action, and these all RDDs and transformation are at single place, so Spark can take a data-driven decision, wise decision based on some optimizers, that okay, which operation is more optimized when we want to perform it, right? So let's say if in RDD1 we are reading a file, if in RDD2 we are filtering only rows containing something, then what Spark can do for you, even though you will read the file first in your code and you will filter the file after reading the file, what it will do, it will push this filter to the source file, and only reads the filtered rows. So the data flows through the network will be very less. And this is one of the optimization. Spark can do many cost-based optimization, or maybe some performance tuning, whatever the code is written, right? Now, we know that, okay, whenever we do a transformation, a new RDD will be created, a new RDD will be added as a node into the DAG. The transformation will be added as an edge into the DAG. Now, one more thing which is important, right? The transformations are further divided into two categories, right? The first transformation is called narrow transformation. Now, the narrow transformation means, what we can clearly see here, that, see, in RDDs, the logical thing is partition, the physical thing is block. So block on SDFS will be mapped to partition of RDD, right? So there is one-to-one mapping between block and RDD, block and partition of RDD. So if you see here, so let's say this is partition 1, and here it is B1 in data in SDFS, here is B2 in SDFS, here is B3 in SDFS. So what narrow transformations say, that if you are producing same number of partitions or same number of rows as the input partitions, then it is narrow transformation. One more thing, if you have to do no shuffling. So what partition means? Partition means we are processing data from one block. So we have a hard disk here, and then a hard disk means we have HDFS here, and then we have RAM here. It means your partition. Let's say if we want to do some operation on each element of this block one, let's say we have 100,000 rows here, right? And we want to add one to each row. So it means all the data for this addition is present into this block or into this partition. So we do not need to go to any other partition. There is no shuffling required. The data do not need to be read from any other partition. So let's say if you want to add +1 to each and every partition. So what it means, all the data for this +1 addition is on partition 1. So the partition 1, and here the 1 will be added to partition 1, and the result of this RDD2 is RDD 1 plus RDD 1 plus 1, kind of this. So it means we do not need to do any shuffling. So whenever we do not need to do any shuffling, that transformation is called narrow transformation, right? Now the question arises, what is wide transformation? So obviously wide transformation means whenever we want to do shuffling to perform that transformation. What can be different operations? Let's say we want to join two operations, right? Whenever we want to join operation, let's say if we are joining data on different blocks or different data nodes, so nobody can assure that, okay, let's say if we have data like this, we have employee ID 1, 2, 3, 4, 1, 2, 5, 6, 6, 8, 9, 10. And if I want to bring all the data of employee ID 1, so one thing we can clearly see here, that employee ID 1 is on partition 1 and partition 2. So if I just read the partition 1, the data is not full. If I just read the partition 2, data is still not full. We need to read the data from all the partitions which have that employee ID. So in this case, we will need to do the shuffling and bring data to one partition so that we can perform some join. So in this case, let's say 1, 2, 3, 4, 1, 5, 6, 6, 7, 8. So here what we'll be doing, we will be bringing all the data of 1 here, right? 1, 2 here, and let's say 5, 6 here, or 7, 8 here, something like this. So we need to do the shuffling. So data from different partition will move to another partition so that the data which is required for the processing can be present on a single partition. And that's where here shuffling is required. So when we talk about wide transformation, here shuffling of data will be required, and that's where the wide transformation are expensive, right? And wide transformation means whenever we are grouping things, when we are reducing by key, right? So let's see the definition quickly. So narrow transformation are the result of map and filter function, and this is just examples. There can be a number of narrow transformation. Those compute the data that live on a single partition, meaning there will not be any data movement between partition, and thus they are executing narrow transformation, right? When we talk about wide transformations are result of group by key, reduce by key type of function. These compute data that live on many partitions, meaning there will be data movement will be partitions to execute wider transformation, right? So this data, this requires shuffling of the data, and they also called shuffle partition or shuffle transformation, right? So this is very important. Now let's go to, okay, one more thing. I have already covered whenever we do partitions, there is a DAG created behind the scene, right? So for transformation, whenever we do transformation, Spark adds them to the DAG of computation, and only when driver requests some data, the DAG actually executes. So what it is doing, whenever we're doing transformation, it is adding them to DAG, and then once we do some action or when driver needs some data, then only DAGs will be executed. Now this is very important. One advantage of this is that Spark can make optimization decision after it had chance to look at the DAG in entirety, right? This would not be possible if it executed everything soon as it go. For example, if first RDD we are reading data, which is 10 gigs of file, and then we are filtering data. If we are executing one RDD as soon as we hit enter, it means if RDDs are not lazy, Spark won't have the capacity or won't have the option to optimize the things, right? Because it cannot see what exactly as a programmer you are planning to do, right? It can only see one line at a time. But what DAGs allow Spark to do, it can see the whole program, what a programmer want to execute, and it can see the the decision by taking the looking at the data in entirety, right? For example, if you execute every transformation eagerly, what that means, just give me a second, guys. What it means is, so what it means is, if you execute every transformation eagerly, what does it mean? That it will not, every time when you hit it, it will materialize it. So there will every time when you hit, let's say if the RDDs are not lazy or the transformation are not lazy, it means that Spark won't be having that option to optimize it, right? So what it is written here, that it means you will have to materialize that many intermediate data result in the memory. So first of all, you need to bring that 10 gig file into memory, then you need to filter that 10 gig file, and then you need to do some sorting in that 10 gig file and all, right? And this is evidently not efficient, right? And for one, it will increase your garbage collection cost. I'm just telling you something, right? So there are benefits of lazy evaluation, there are benefits of DAG creation, and these are few of the benefits. That okay, every time when you hit a transformation, you do not need to do the execution at the same point, you just need to add the nodes into the DAG, right? Once on the calling of action, the DAG submits a DAG scheduler. I'll cover DAG scheduler and everything in a lot of detail. But when you hit action, what is going on behind the scene? So let's say when you hit action here, so anything what you have done till now, you will create a DAG here, and you will submit a DAG to the DAG scheduler. And then DAG scheduler will further splits the graph or the DAG into stages of the task, right? And on what basis stages, like there will be a lot of detail I will cover on stages, but according to you guys, what stages can be? Stages can be that okay, if your data is available on a single partition, then there is no need to create for a staging. But if you need to shuffle things, it means if there is a narrow transformation, all narrow transformation will be on single stage, because there is no need to move data here and there. But if we need to move data here and there, let's say after filtering, we need to move data to something else, then what we need to do? We need to put this data somewhere into the memory, and then we need to read this data again. So once we write data to some temporary memory and reading it again, and we are writing this data from multiple partition into this memory, then we will create a new stage. So whenever we are hitting the byte transformation, we are creating a stage, right? One more question is, when we talk about MapReduce, right? So this is what was going on in MapReduce, that whenever we are doing some operation in MapReduce, each operation is independent of each other. Even your Hadoop as a system don't know what the next operation gonna be. So for example, let's say you perform first operation. Let's say you want to calculate the number of occurrence of words, like word count program. What you're gonna be doing? You're gonna be reading the file, right? The second, you're gonna be mapping the file with 1. The third, you're gonna be the second, you're gonna be splitting the file into words, and then mapping with 1, 4, counting. if you do this thing in MapReduce, what was going on, that every line or every action, whatever you want to call it, every operation is independent to each other, right? And that's where MapReduce will write everything. Once it's read the file, it will write into hard disk. Then this hard disk will read this operation will read it from here. Then map will read it from here. So every time you need to go for, and that's where you need to go for SDFS. And that's why the Hadoop as a whole cannot optimize your code. And this is where DAG will come handy to optimize your code and the memory in memory processing, right? Now, what is the proper definition of action? Transformations create RDD from each other. When we want to work on the actual data set, at that point, we perform action. When action is triggered after the result, new RDD is not formed like transformation. Thus, actions are Spark RDD operation that give non-RDD values. A value of action are stored to the driver or to the external storage system. So one more good thing about what's the difference between action and transformation? Transformation will always produce RDD as a result. Action will produce non-RDD things. Non-RDD means primitive data types, maybe some file or maybe something else, right? And this non-RDD result, whatever you want to have. So action means you want to have some result from the processing what you have done. So this non-RDD things can be, you can see on the console. You can see on the console. When we talk about console, we always talk about driver console. I'll talk the driver, but when we talk about console, it's a driver console. Okay. And when we talk about non-RDD, it can be file as well, which we can store into SDFS, which we can store into S3. So this result of the action can be a output which we can display on console or we can store it somewhere. But it's a non-RDD thing, right? Now let's coming to Spark RDD operations in bit more detail. So Spark RDD operations are further obviously transformations and action, and I will cover each and every in lot of detail. But the most commonly used transformations are this one, like mapping the thing, filtering the thing, flat map, map partition, group by, sort by keys, right? And this transformation can be narrow transformation, can be broad transformations, right? And when we talk about action, see, action is all about when you are asking system, okay, give me now, give the result to me now. For example, counting the things, taking the sample, asking the system to give me the max value, minimum value, sum, histogram, mean, variance, right? Anything. And from here itself, you can see that in most of the transformation, in most of the action, it's obvious that you are asking system to do something for you, to do some action, right? Here you are asking system to save the text file. So to save the text file, to perform this action, it will do all the transformation on the RDDs and then it will save the text file, right? One more thing is, which I covered in the Scala lecture. So we have tuple, right? We have tuple, and tuple can be a combination of multiple type of data types. So tuple can be of string and integer, or maybe a number of things. But when we have tuple of 2 elements, let's say Nilendra and my age, we call it pair tuple or pair RDD. In Spark, if we have tuple with 2 elements, we call it pair RDD. So if we have a RDD, in more simpler terms, if we have a RDD with 2 elements, we will call it a pair RDD. So Spark pair RDD is nothing but RDD contain key value pair. Okay, because key value pair consists of 2 linked data items into it. Here the key is the identifier, whereas value is the data corresponding to the key value. So it means here the key is Nilendra and the value gonna be my age. So obviously Nilendra name has been linked to the age. So there's a relationship between key and value. Now the question is why I'm telling you this type of RDD in a specialty. And the answer to this is, in Spark, we have lot of operations which are very specific to the paired RDD. So it means if we have a RDD in which we have 2 elements, you can do this type of special operation on the paired RDD. Like you can have flat map values, group by key, reduce by key, folded by key, sort by key. And here, when you see key, we are talking keys about paired RDD. One more thing is important here. Here, if you see, the question what people ask, reduce by key, okay, this thing, right? So reduce by key is a transformation, but reduce is an action. Am I making sense? So this is the interview question, which lot of people can ask you. So when we do reduce, action will be triggered and DAG will be submitted to DAG scheduler and everything will be taken. But when we go for reduce by key, only transformation is only the one node will be added to the DAG. It means when we do reduce by key, a new RDD will be created for you. When we do reduce, an action will be triggered, right? I will cover this action in a lot of detail, but the paired RDD is the important thing. So please keep that in mind. Now, let's talk a bit about Spark architecture, right? So when we talk about Spark architecture, and there will be a separate lecture for Spark architecture, but since it is here, let me cover it in 2 minutes. So in Spark architecture, you have basically, Spark is also a master-slave architecture, right? Master and slave. So in Spark, we call master as driver and slave as worker node. So this is your master and these are your slaves. The same thing in SDFS, we have name node and data node. In MapReduce, we have task tracker or job tracker or something. Here we have driver program and worker node, right? In between, we have some cluster manager. This cluster manager can be Yarn or Mesos or Kubernetes or maybe standalone, something like can be any cluster manager, right? What you do as a programmer, you submit your program to the driver program or to the driver, right? And what this driver will do for you, driver will create the RDDs and execute this RDD in some way, and that some way is very detailed explanation. I'll cover that later. In some way into this worker nodes. So let's say when you read a file RDD, when you read a file from SDFS or from some local, and you submit that line into driver program, it will create RDD. It's a functionality of driver program to create the RDD, right? The result can be stored or showed on the driver program, but it's not preferable, right? So one more thing is driver program is the entry point to the Spark. Like in Java, you have main class. In Spark, you have Spark context or Spark session. You have two things. I'll cover this in a lot of detail, but you have Spark context that we call as SC or Spark session, which we call Spark. So these two things are the main program or the entry point to your Spark programs. Okay. Now let's go to your how to open Scala Spark program into your Cloud Rocket VM, right? So what we can do, we can simply type Spark shell. So now when you type Spark shell, what it's gonna be doing for you, it will open a Scala REPL for you. Okay, but one more thing which is important, which I need to show you here. When you type a Spark shell, it will automatically create a Spark context for you. The Spark context means entry point to the Spark environment, so that whenever you use that Spark context to talk to or to write a program, it means you want to distribute that computation into the worker nodes. Okay, so let's see here. It has been done. So when you see here, Let it be open quickly. So what it is doing right now, it's opening a Scala for you. Okay, this is important, right? So what this guy did for me, it created a Spark context for me, right? It created a Spark context for me. It means it created a Spark context as SC for me. And this SC means that if I want to execute something on Spark cluster, then I need to go through SC. Now let me tell you one thing what I mean, right? So let's say if I write here print Nilendra. So according to you guys, where this code is running? Is this code running on Scala or is this code is running on Spark? Since I have never touched SC here, it means this code is running on Scala. It is because we haven't opened the door using SC of the Spark cluster. So what SC is? SC is a door through which you need to enter the Spark cluster for the distributed computing, right? So what Spark is? Spark is a distributed computing framework, and to enter that distributed computing framework, you need to have some door, and the door is SC for you. Okay, so let me tell you in this way. So now let's see. So here, if we go into Hadoop FSLS -10, let's say. In fact, let's do one thing, right? Let's say if I'm creating something, well, A is equal to 1 to 10. Okay, so what it did, it created a value for me from 1 to 10, but this value is just, you can see here, this value is just a collection of range, right? Now let's say if I want to create a RDD, if I want to process this A to 10 in Spark, what I gonna be doing, I'll say, well, B is equal to SC dot parallelize. So don't worry about parallelize, but I'll say something like SC dot parallelize. One second, guys. Parallelize parallelize A. Okay, one second. SC is there. Perfect. And SC dot parallelize there as well. And I'll parallelize A, and I'll store this in B. Okay, so what I'm trying to do here, it's in a very layman term, what I'm doing here, that I have created one set or one range from 1 to 10, right? I have created one range from 1 to 10. Now let's say if I want to process this range in Spark, then I need to tell Spark, or I need to send this range into Spark in some way. So what I have done here, I have used a method parallelize from Spark context on range, and then as a result, what it did for me, it created a new RDD for me of type int, right? And what this RDD is just a parallelized collection. So ideally, don't worry about this parallelized collection and everything. What I'm trying to show you here, that to use Spark cluster, you need to use SC first thing, or Spark, or maybe SQL context, but you need to use some context, maybe Spark context, maybe SQL context, or maybe Spark session, like 3 things, right? Or Hive context, some context. Okay, so let's, and this is the most important thing when you want to execute a code in a Spark, right? So let's go to our notes. And this is where this Spark context or SC will come here. So you will submit your code to SC. So when I go here, so I have submitted my code using SC. Now, most important thing, once this RDD is created, so RDD means what? RDD means that this is now the data structure what is created, Spark can read it. So RDD is something what Spark can read. So do you need to use SC again and again? The question is, do you need to use SC again and again? No. You just need to use the door. You just need to open the door once. Once you have created some RDD, that is done. Now you do not need to use something. Let's say if I want to do something else here, let's say val B, let's say val C is equal to B dot, let's say I want to do some mapping, right? And I want to do X goes to X plus 1, something like this. And so what I'm doing here, I have, see, one more thing. So I have created one RDD. I have do the same thing. I want to add one number to it, right? And now let's say if I want to create one more RDD, val D, and now I need to perform on C, and I want to add all elements by 3, right? And now let's say if I want to see what kind of DAG is created behind the scene, what I can do, I can say D dot, I can see from here, D dot debug string, something like this. So what this function will do for us, it will tell us, one second. One second, guys, sorry. I need to find the syntax quickly. So to debug string will show you the exact lineage or the DAG, but I forget the syntax here. So let me see. Okay, so I have done the same thing. Okay, so to debug string, we do not need to use this. Okay, one second. So I'm doing the same thing. Okay, so we do not need to use the brackets there, right? So see here, what DAG is created. So what I did, I read the file, I read the A as a range, I created a RDD B adding 1, I created a RDD C adding 3. This one I created a new RDD, then I created a one more RDD, then I have done debug string onto that last RDD. So what is going on? You need to read this DAG from bottom to up, So what we did here, and this is how Spark is reading or reading behind the scene. So you have created this one parallel connection. You have read the RDD, you have created the map partition, and you have created the map partition again, right? And once, let's say, if I want to collect the data, so what it will do? It will show me data onto the console, right? Since I'm working in a single cluster, so what my A was. So my A was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? First I added 1 and then I added 2. So in every number, first I added 1 here and then I added 3. So I totally added 4, right? So as a result, what I get here, that 1 plus 4, 5. And in every number, I have added 4, 4, 4. But I added those 4 into 2 steps. First, I added 1, then I added 4, right? Then I did 3. So ideally, this is what is going on behind the scene. So what it did, it parallelized the thing, first thing, it will map the thing, and it will do the mapping again with the 3 operator. So this is how your DAG and your transformation and your action is taking place. One more thing which is important here, right? Let's say if I want to store this result into X, and I will say val X, right? So what is going on behind the scene? See this thing. What it gave to us? It gave us array. It gave us array. But whenever, let's say, if I do some mapping again, right? If I do some mapping on D, and I'll say X multiply each element by 2. What this, let's say we create Y here, what this Y will be? Y will be RDD. So whenever we are performing some transformation, the result we are getting is RDD. Whenever we are performing some action, the result we are getting non-RDD thing, a primitive data type, or maybe some file, or a number of things. Okay, so I am just proving that thing. And behind the scene, DAG is created for you. To see the DAG, we can use 2 debug string with at any point of time, just to see where are we, right? So this is good. Okay, now let's go for the famous word count program, right? So I remember I have shown you the word count program into MapReduce, and this is how your word count program code looks like. So you have your main code, right? You have your map code, you have your reduce code, and so at least you need to run to just count the number of words. You need to write 50 plus or 60 plus line. Now when I go for Spark, you just need to write 5 lines, 1, 2, 3, 4, 5 lines. And even you can do the whole this computation in 1 line. I will show you later. But if you want to, for beginners, we can do the same program in 5 lines. So let's do it quickly, right? So let's see how word count program work. So we'll go here. What we're gonna be doing, we will create a one file here. So let's say vi test file.txt, and I'll write some words into it. Hi, my name is Nilendra, and I am teaching big data to big people with big minds and big aspirations, right? And I'm sure they will achieve big results, kind of, right? So I wrote this thing, right? And I'll save it. Okay, now let's do one thing. I'll show where I'm at. I'm at home Cloudera. Let's say if I want to put this data into temp test data, okay? So what I'm gonna be doing, I'll say Hadoop fs -put test file.txt, and where I need to put? I need to put here, right? Copy it and then quickly paste it and hit it, right? So what I did, I created a file for you guys, and I need to count the number of words into this file now, and I'm putting that file into HDFS. Now we will open the Scala Spark Shell terminal, and then we will read one by one, right? So let's start the program now. So what we will say, well, file name or file read, we can give any name here. And then since we need to enter this program into Spark cluster, then we will start with sc dot, we will read with text file. sc.text file, and then in the double quotes we need to give file temp, and then where we put temp test data, and then our file name is test file What's the file name? Testfile.txt, right? Testfile.txt. So it created something for us. What it created? It created a RDD for us. The name of the RDD is file read. What is the RDD type? RDD type is string, right? Now let's say if we want to, so we know that file has been in this structure, right? This structure is the file. So the file has been, the file is a combination of words, and the words have separated by space, right? But we know that in this file, the multiple words are at the same line. So let's do one thing. We need to create a new, well, let's say we need to, from the sentence, we need to take the words. So what we will say? We'll say file read. Now, obviously, since we have first RDD and we need to, and we know we cannot change this RDD, we need to perform some transformation on this RDD. We'll say file dot flat map. Yeah, flat map. And then inside the flat map, we will say split. We'll copy this code. We will say split, and split on based of what? So we will say split anything which is coming, like space means this underscore means what? Any line which is coming from file read, split that line based on space. Okay, so we'll hit this thing. 1 second. What's saying? Word flat map. Oh, sorry. M should be capital. It will always be in camel case. Okay. So 1 second, guys. So it will be like this. Okay. So what I did now? So I have created two RDDs. First RDD, I have read the file. Second RDD, I have divided the each line into word. Let's say if I want to see how the words is looking now. So I'll say words dot. Let's say what operations we have available. So we have, I'm just seeing how, let's say take 5. I need to take the first 5 thing. Okay. So what I'm seeing here, that okay, this is fantastic, right? So what I did, I read the line, I splitted the line into multiple words using flat map function and using space as the split delimiter, right? So what this flat map did for me, it created an array for me. Right? Now what we need to do, we need to, let's say now we have, hi, my name is Nilen, right? So what we need to do now, we need to put something like hi, comma 1, I, comma 1. So we need to do something like this. So one thing is very sure, that we need to put 1 in each element. So whenever we want to loop through each element, we will always go for map. Right? So what we go here, we will say word map is equal to, on which RDD we need to do the map? On the words, right? Words dot map, and then inside this map, what we need to say? We need to say x implies to x, comma 1. What I say here, that on each word, let's say how map function works, right? So in map function, we have this anonymous function, right? What this anonymous function says, that each input element add 1 to it. Simple. Don't do anything extra, just add 1 to it. So let's say, well, here, so what it did, it will add 1 to it. Now let's do one thing. Let's see what the output is, right? Word map dot take 5. So what it did, again, it created an array for me. Hi, comma 1, my, comma 1, and name, comma 1. So I have array like this. I will copy it for your purpose. So I have array like this, right? And then what output came here? I have, when I did the map function, the array is like this. So this is using flat map and this is using map. So first of all, I have line like this. I have line like this. Hi, my name is Nilendra. Then I have applied flat map on this line. Then it converted that line into array. Then I've applied map into it, right? And then what I'm gonna be doing now, one thing is sure now, that this is paired RDD. This is paired RDD. This is paired RDD. This is paired RDD, right? So we have paired RDD. Now, if in the paired RDD, this is key and this is value, like 1 is value and word is key. So if we just count the number of words and add these ones, we will get the number of words, right? So what it is doing here, let me explain it to you, and let me write it down in a more simpler way. This is complicated. So what I'm doing here, so if I say here that val result is equal to word map dot reduce camel case by, so we'll always go for camel case, by key. Reduce by key, we need to give some anonymous function, right? So we're gonna be saying x comma y implies x plus y. 1 second. 1 second. So what it did, so it did splitted, it did map. 1 second, let me use this. It should also give the same error then. Dot this paste. It worked. 1 second, let me think. So reduce by key and x plus y string comma int. Not sure. Basically, these two are almost same. I need to think about it. But what I'm doing here in reduce by key, how reduce by key works, that reduce by key will see the key. If there is same key, it will add the first element and the second element. So let me explain in further details. So let's say you have hi comma 1, I comma 1, and let's say hi comma 1 came again. So what reduce by key is doing, reduce by key, and let's say if a hi comma 1 once more. So first it will see how many keys are the same with the same key. It will put them together, hi comma 1, hi comma 1, hi comma 1, and then it will take the first two elements of the key and it will say hi, and it will add them this one. And then when I say this plus this, what it is really doing, this one will go here, this one will go here, and it will say 2, hi comma 2. Now next time what it will do, it will take this h, since it will say hi is here as well, and then it will say hi 2 plus 1, 2 from here and 1 from here, and the result gonna be hi comma 3, right? So this is how the reduce by key works. So now what we see here, that result of this is word map dot reduce by key is RDD, right? Now let's do one more thing. Let's say result dot collect. So what it's gonna be showing me, it will show me the array of all the elements with their count. So what I'm doing here is came 1 time, people came 1 time, and since I wrote the big for the 5 time, it came 5. So see how simple it is, right? So how many lines I written? I written in total, I have written first line, I read the file, right? File read. The second line, I have splitted the file into words. The third line, I have added 1 to each word. The fourth line, I have calculated, like I have summed all the ones of same type of words. And the fifth line, I have collected the words, right? And in the 5 line, we have done the word count program, which was done into 50 to 60 lines in Java, right? So this is how, one more thing, let's see quickly. So we have result here, right? Result that to debug string. Okay, this is very interesting, right? So what I've done here, I have shown you the DAG, how it is done behind the scene, right? So what we did here, we first read data from Hadoop RDD or Hadoop file system, and we read this file, right? So we read test file.txt, right? On that file, we have done some mapping. We have done some mapping onto, okay, very good example I'll show you now. On the map partition, we have done the flat map, and then we have done the map, right? So ideally, we have done only 3 things, and then we have done the reduce by key. Okay, so when you see here, how many operations we perform? Okay, this operation I performed, I remember. Then I performed the flat map. But what Spark did for me, and obviously I'm not sure why it did, it moved the map operation before flat map, something like that, and then it again did the map. So this is how, since it has all the operation what I have performed in entirety, so it moved some operation or some transformations to make the wise cost effective decision. Okay, and this is how it works, right? One more thing is, let me show you. When we go here and when we go for localhost, one second, localhost on 4040 port, ideally it should open. Yeah, this is what it is, right? See, so this is Spark UI for you guys. I have a separate lecture on this Spark UI, but what this is showing you that, okay, I have Spark cluster open for uptime is 28 minutes, right? Scheduling mode is again first in, first out. How many jobs I have completed? The latest job what I have completed is this one. So let's say if I want to go here, right? And if I want to go here, in fact, let's go quickly one step back and let's see the DAG. Let's see the DAG. Okay, this is very good. And the same thing what I was showing you about stages, about transformation, operation, different kind of stuff, right? So what DAG shows here, that this is how Spark, would have read the data behind the scene. So first it read the file here, it read the file, then it did the flat map. One second, guys. Okay, here. So it did the flat map, then it did the map. And since I did the reduce by key, and reduce by key is a wide transformation, so map and flat map are narrow transformation. I have shown you here. So map and flat map are narrow transformation, and reduce by key is a wider transformation. So what it did here, it created a separate stage for me here. It created a separate stage for me here, right? So all what it means, what this pink line means, that data for this stage is available on single partition. Data for this stage is available on single partition, right? So this is how the DAG visualization works, right? And then at the end, it needs to read data from other partition for the reduce by key. So it means it needs to shuffle the data. It will, for the map has written it data here, where my cursor is here, and then it read the data into reduce by key. Okay, and this is how the DAG visualization work behind the scene. Okay, so one thing, whenever we need to interact with Spark, we need to create, we need to go with Spark context, right? First thing, if we don't have Spark context, let's say, see, this is Spark shell, right? This is Spark shell. So Spark shell has created a Spark context SC for us, and this Spark context is created for us by Spark by default. But let's say if we want to do our development into some UI or IDE, we need to create this Spark context, right? Now let's see how word count program work in any IDE. So guys, I have downloaded the Scala ID for you guys, right? And then what I did, I have told you that to interact with Spark cluster, we need to have a Spark context created for us. So what I did here, and I'll cover this thing in a lot of detail, don't worry. So what I did here, I created a Spark context, right? And I asked the Spark context that, okay, you need to run on my local machine, right? And name of your application is word count program, right? And then I did the same thing. Forget about this. So I did the same thing. I created one file into my local. This is my local file in which I written, hi, how are you? Let's say I write more words. I am good. Hope you are fine too. And studying well and big data is wonderful, right? And I saved it, right? And then I go here into my Scala here, and then I read that hello.txt. Then I did the same thing. I go for flat line, flat map. I go for map in the same line, and I assigned 1 to it, right? The same thing what I did. Then I did the reduce by key. I collected it, and then I printed it, right? Now let me run this program. So what I'm showing you here, I'm almost doing the same thing. The only thing which I did different is I have created my own Spark context to interact with my local Spark cluster, right? So let's go here. And this has nothing to do with your Cloud or Quick VM. I have installed Spark on my local, and then I have integrated this Scala ID with local Spark. It's very simple. I'll show you in next lecture. But since, see, this is what it did for me, right? Almost same thing. Okay. So two most important thing, that to interact with the Spark cluster, you need to enter with the Spark context. And for one program, you can only enter once through the door. It means you need to, for one program, you need to use the Spark context only once, right? Let's see one more thing here. Localhost 4040. So this is my local host on my local, right? And when I go for completed jobs here, so I see the collect, and exactly same DAG created for me here, right? So again, reduce by key is a wide transformation, so it's created in next stage. Stage 0, or the first stage, we have only 3 operations. These 3 operations are the single stage because my data is available in one partition, right? For reduce by key, by default, it thinks that, okay, it may need to read data from another partition. So by default, it is a wider transformation. Okay. So this is all for today. Tomorrow, we're going to be covering a lot of detail about DAGs, about Spark UI, different kind of stuff, right? So do go through this recording.